Hi guys, my name is Matt Stock, and today we're going to be talking about production within microeconomics, and particularly the comparison of average product versus marginal product and the production function itself. So to start, let's talk about the production function. So production function is basically going to give us the highest output from a specified combination of inputs. So today we're just going to use two inputs to keep it simple. We're going to have labor, our amount of workers, and capital, basically our amount of machinery. And so we want to know how much labor and how much capital, how much of each to get our maximum amount of output. And again, this is very important to know because as individual firms, we want to know how much we should use of each in order to get the most output. And so to kind of give like very, very simple terms, probably not realistic, but keeping it simple. Say we have a car firm and we want to know how many cars we can make. We want to know how much labor we need to hire and how much capital we also need to rent. So within capital and labor, there's two terms that we really need to distinguish and keep clear, which is average product and marginal product. So today we're going to talk about the average product of labor and the marginal product of labor. We could also kind of do the same thing for capital, but today we're going to talk about labor. So let's start with the average product of labor. Now this is basically going to be our total output per unit of labor for a particular product. So it's going to be our total output over our amount of workers, our labor input. And what this basically is going to do is going to measure the productivity of our firm, of our company, in terms of how much on average each worker can produce. And we can see that mathematically, right here. Here's our average product of labor, and we have our total output over our labor input. And so to give a very simple example, say you have a firm that produces cars, and you are producing 10 cars with 5 workers. That means your average product of labor is 2, meaning on average each worker is producing 2 cars. Now, distinct from that is your marginal product of labor. Now, marginal product of labor is, I always like to think of marginal in the terms of economics as one more, as a change. So marginal product of labor is basically how much more output you get by adding an additional unit of input, in this case an additional unit of labor. So we can again represent that mathematically through your change. Again, marginal is always change. Your change in output over your change in labor input. So again, to kind of give an example, a very simple example, say you have your car firm again and you hire one more worker and all of a sudden you are producing 3 more cars. So that means that your output changed by 3 when your workers changed by 1, and therefore your marginal product of labor is 3. And so what we really want to now think about is comparing the two, comparing average product with marginal product. And it's really important to kind of make sure we know, when one is increasing and one's decreasing, etc. So again, we can show the two together on a graph. And here, this line we have our marginal product, and on this line we have our average product. And so we can see pretty simply from this graph that when marginal product is greater than average product, see that it's this black line's above the red line, that when marginal product is greater than average product is increasing. Then we can also see that when marginal product is lower, average product is higher on the graph, than marginal product, we can see that average product is then decreasing. And finally, we can see that when marginal product and average product intersect, that's when average product is at its highest. So it's can be kind of confusing to kind of keep those things straight, and it's very important too, because I know that a lot of the times a quiz or a midterm question might be, when marginal product is greater than average product is A increasing, B decreasing, C the same, etc., etc. And so without kind of having the graph, it's important to keep them straight, and that's why I kind of like to give kind of a mental representation to the whole thing. And so what I like to think of is a classroom of students. So say you have a classroom of students that's a B average. So that classroom basically represents your average product. Now say, hypothetically, that you have an A student transfer into that B classroom. So the addition of the student is, of course, the marginal product. So when you have an A student transfer into a B class, that means your marginal product, your one student, is greater than your average product, the class. So in that case, when the A student transfers into the B class, the average grade is going to go up. So similarly, when the marginal product is greater than the average product is increasing. Now, on the contrary, say you have your B average class again, but now you have a C student transfer into that. Okay, so this marginal product is now less than the average product. And so when you have a C student going into a B class, your average is going down, and so your average product in this case is decreasing. So again, it can be kind of confusing at the start, but again, if you kind of think of that idea of the class as your average product, and then either, when your marginal product is greater, that's your A student going in, average product increasing, marginal product's less than average product, that's your C student going into the B, average product is decreasing. So I hope that helps to kind of keep those two straight. And then two more things to kind of note with our graph is that you can kind of see at this 8, that's when marginal product is 0. And that's important because that's when total output is at its maximum. And we can kind of think about that as we kind of thought about marginal product in terms of when you're adding one more unit of labor, but you're not getting any more output, that means there's no reason to add any more labor. And so therefore, when marginal product is 0, total product is at its maximum. And then finally, an important thing to note, as I kind of mentioned earlier, is that when marginal product crosses average product, that is when average product is at its maximum, which again is very important because that's when your average worker is producing the most. So that's kind of a basic teaching of the concept of average product and marginal product. I hope that helped, and please let me know if you guys have any other questions. Thanks.